Magnetism is everywhere. It's in our phones, our computers, and our fridges. Earth itself is a magnet. How does it work? How do magnets and electric wires attract and repel each other? It's all because of electric charge. You might have heard that whenever an electric charge moves, it forms a magnetic field. But why? This can be explained with special relativity.
The theory states that the only absolute thing in the universe is light, and that distance and time are not absolute. This means that some pretty wacky things start happening when you approach the speed of light. Basically, as objects get faster and faster, the mass of those objects start increasing towards infinity, and the space and time around it seems to squish together. It happens all the time, but the effect is so tiny it's considered to have no effect. For example, an object traveling really fast might travel 1 second from its perspective, but to an observer from Earth, it might have traveled for a whole day. Now let's say you put two wires next to each other, and there's a current moving through them in the same direction. To us, we see electrons moving through both wires at the same speed. But in the reference frame of the electrons, which are traveling at a really high velocity, the nuclei in both wires, which are positively charged, seem to be contracting, so both wires become positively charged. The wires then repel, but to you and me, it looks like two neutral wires repelling each other. Scientists name this force magnetism, even though in reality, it's just electrostatic forces disguised behind special relativity.
But what about permanent magnets?
Well, matter is made up of atoms. Atoms are made up of protons and neutrons in the nucleus, and electrons orbiting around it. Every electron has a property called quantum spin. Electrons have this property called angular momentum, which simply means it spins around. The way it spins around, clockwise or anti-clockwise, determines if it is an upspin or a downspin. This then forms a microscopically tiny magnetic field. Electrons also like to group together in pairs, and in these pairs, one electron has to have an upspin while the other has to have a downspin, essentially cancelling out these magnetic fields. The unpaired electrons, however, can form magnetic fields without cancelling out. If the unpaired electrons in all the surrounding atoms line up the same way, forming domains, the magnetic field becomes stronger. When all the domains in an object match up, the material becomes a magnet,